Welcome to the deep dive. Today, we're getting into something technical that, well, it trips up almost every RC hobbyist eventually. We're talking about getting your Fleisky transmitter, the radio you use for your drone or your car to actually talk to your PC simulator. And if you've tried this, you know the feeling. It's not like plugging in, say, an Xbox controller. It's definitely not plug and play. There's a bit more to it. So, our goal today, our mission, is pretty straightforward. Cut through all that complexity around RC connections and give you clear, actionable steps. We want you to get past the driver confusion and straight into that consequence-free practice, which, let's face it, is way cheaper than fixing a real crash.
Absolutely. And that plug-and-play expectation, that's really where the trouble starts, because the setup is fundamentally different. The simulator software, that's all in your PC. The Fleisky radio, when you connect it up, it's just acting as an input device. Think of it like a very, very specialized joystick. Yeah, the analogy I like is your transmitter is the steering wheel and pedals. Your PC, that's the engine doing the processing. The simulator software itself is the road, the virtual world. And the connection, the cable or adapter, that's the steering column. It has to actively translate what your hands are doing into something the PC's engine can understand. If that steering column is the wrong type, or it's faulty, well, the whole thing just doesn't work.
Right, that makes sense. And I guess that leads to the first hurdle, the sort of modular nature of the hobby.
Mm.
Why is it so different from, regular consumer gadgets? Why this extra step?
Well, it really goes back to the history of the RC hobby. These parts, transmitters, receivers, servos, they were designed to be mixed and matched, to be flexible. They weren't originally intended as these tightly integrated systems like, say, a game console controller that only talks to its specific console. This legacy means you often need that extra bit of hardware to bridge the gap to a PC.
And you can literally see that legacy on the back of the radio, can't you? That physical port.
Exactly. The trainer port, sometimes it's labeled DSC for direct servo control.
Okay.
And yeah, you'll usually see an older connection standard there, maybe a 4-pin mini dyne, sometimes a PS2 connector, or often just a basic 3.5mm headphone-style jack.
Mm-hmm.
Its original job, the reason it was put there, was actually for flight training. You'd connect the student's radio to an instructor's radio.
Ah, for buddy boxing.
Precisely.
Mm-hmm.
But for us, that port is the gateway for the signal we need to get to the simulator. And that signal is usually pulse position modulation, or PPM.
Okay, PPM. Now, here's where I get a bit fuzzy. You said it's an older analog signal. So how does the radio take, I don't know, maybe 6, 10, even 18 different controls, throttle, steering, switches, everything, and cram all their positions into just one continuous signal? It sounds complex.
It is clever, but it's all about timing. It's not magic, just smart engineering. PPM doesn't send digital ones and zeros. Instead, it encodes the position of each channel by varying the duration or the timing of little electrical pulses. So a really short pulse might mean, say, 0 throttle. A longer pulse could mean full throttle, and it just strings these pulses together one after another for each channel in sequence. That continuous stream of varying pulse lengths tells the receiver, or in our case, the PC adapter, exactly where every stick and switch is at that moment.
Okay, so we've got the stream of analog timing pulses coming out the trainer port, but the PC's USB port, that speaks modern digital language. They don't understand each other directly.
Exactly. You need a translator. And that translator is the USB simulator adapter, the dongle. And here's the absolute key thing to grasp. This is not just a wire. It's an active electronic device. Inside that little plastic case, there's usually a small microcontroller chip and an analog-to-digital converter, an ADC.
So it's actually processing the signal.
It has to. Its job is critical. Receive that analog PPM stream, precisely measure the timing of those pulses, and then translate those timings into the standard digital format that USB uses for controllers. It translates it into the USB Human Interface Device Protocol, HID. That's why when you plug it in and look in Windows, the PC sees a generic game controller or maybe PPM device. It doesn't see Fleisky FSI6 or whatever your specific model is. The dongle handles the identity part.
Right, which brings us neatly to the cable confusion. Oh man, this causes so much grief. I swear, if I had a nickel for every time someone grabbed the wrong cable because they look almost identical, well, I'd have a lot of nickels. It's almost a rite of passage, isn't it?
It really is. You absolutely have to distinguish between two types.
Okay, so first, there's the one we want, the simulator cable. An example is the Fleisky FSSM100. This is the active one, the translator we just talked about. It takes PPM and turns it into USB joystick signals for the sim.
Correct. And then there's the imposter, the firmware data cable, something like the FSL001. This cable looks very similar, often uses the same type of connector on the radio end, but its purpose is totally different. It's only for things like updating the radio's firmware or transferring model settings using specific FLESKY software. Internally, it's just a basic USB to UART serial bridge. It speaks a completely different language.
And if you try to use that firmware cable for your simulator,
It will absolutely, positively not work. Your computer won't see a game controller at all. If you look in Device Manager, you'll see something like a COM port or maybe a USB serial port or UART bridge. It's simply not sending control signals.
so rule number one for troubleshooting, check the cable. Make sure it's the active simulator adapter, not the passive firmware cable.
That's the first and often the last thing you need to check if the PC isn't seeing anything.
Okay, assuming we have the right type of hardware, the active adapter, let's talk about the different ways to actually connect. Because it kind of depends on your specific FLESKY radio, right? Older versus newer models.
Yeah, we can basically break it down into three main paths.
Yep.
Path 1 is what most people with slightly older radios use, the standard adapter cable. This means using that FSSM100 kit or a similar third-party dongle plugged into the trainer port. This is the way you'd connect radios like the classic FSI6 or maybe an older Surface radio like the FSGT3B.
Okay, the standard dongle route. What are the downsides there apart from needing the extra adapter?
Well, reliability can be a bit hit or miss, honestly, because a lot of these dongles are, let's be frank, fairly cheap generic devices. You can run into driver problems on Windows sometimes. Occasionally, you might even see the device name show up in Windows as just like garbled characters.
Oh, I've seen that, like weird symbols instead of a name.
Exactly. And when that happens, some simulators just won't recognize it properly. So quality control in the dongle itself can vary quite a bit.
Okay, so that's option one. What's the easier way, assuming you have a newer radio?
That brings us to option 2, modern direct USB. This is the dream, really. Newer FLESKY models, think the FSI6S, the higher-end Noble NB4, or the recent FSG7P. These have the necessary conversion hardware built right into the transmitter itself.
Ah, so the radio itself can act as a USB joystick.
Pretty much, yeah. You just connect a standard USB cable directly from the radio's USB port to your PC. It's generally plug and play.
Nice. Any pitfalls there?
Just one small thing.
Yeah.
The USB cable itself, it must be a proper data transfer cable, not just a charge-only cable. You know, those really cheap cables sometimes only have the power wires connected and lack the data wires inside. If you use one of those, it'll power the radio maybe, but no control signals will get through. So use a decent quality USB cable that you know handles data.
Got it. Data cable, not charge only. Okay, that sounds way simpler. Now, what about the third way? The clever hacky way.
Ah, yes, the DIY microphone port route. This is for the tinkerers, or maybe if you're on a really tight budget.
How does that work?
You basically take a simple 3.5 millimeter male-to-male audio cable, like a basic O cable. Plug one end into the radio's trainer port, assuming it's a 3.5 millimeter jack, and the other end directly into your PC's microphone input jack.
Into the microphone jack, seriously.
Seriously. Then you need a piece of free software. The classic one is called Smart Propo Plus, or SPP. What SPP does is ingenious. It listens to the audio coming in through the microphone port. It treats that PPM signal, those pulses, as if they were an audio waveform. It analyzes the timing of the beeps or pulses in that audio signal and translates that pattern into virtual joystick movements that Windows can understand.
Wow. Okay, that's clever, but sounds like it might need some fiddling.
It definitely does. It's very low cost. You just need the audio cable. But getting the audio levels right in Windows is critical. Too loud or too quiet, and it won't read the signal cleanly. But it can work surprisingly well once tuned.
Speaking of tuning and fiddling, let's talk about the one step that causes probably more frustration than anything else, even if you have the right cable and drivers. Calibration. I know I'm guilty of this. If my controls feel weird in the sim, off-center, jittery, not full range, my first instinct is always to dive into the simulator's settings menu to fix it.
And that's exactly the trap most people fall into. You're trying to fix a foundation problem by painting the walls upstairs. If your controls are fundamentally misbehaving, like the center is wrong, or you only get 80% travel, the root cause is almost always a missed or incorrect system-level controller calibration in Windows itself.
So wait, you're saying I have to calibrate it in Windows before I even launch the simulator?
Absolutely non-negotiable. Think about it. The Windows calibration process is where you tell the operating system the absolute physical limits of your specific hardware. You move the sticks to their extremes, you center them. This tells Windows, okay, this electrical signal means 0%, this signal means 50% center, and this signal means 100%. The simulator software doesn't guess this stuff. It asks the operating system for that baseline calibration map.
Ah, I see.
So if the map you give the OS is wrong, the simulator gets bad data from the start. No amount of tweaking curves or dead zones inside the sim can fix an incorrect baseline map provided by Windows.
Okay, that's a crucial insight. So how do we do that Windows calibration properly?
Right, the process. First, make absolutely sure the transmitter is connected via the correct simulator adapter or USB cable, and critically that the transmitter is powered on in. Most radios need to be on to output the PPM signal or activate the USB HID mode.
Okay, transmitter on.
Second, you navigate into the Windows control panel. The easiest way is usually just to search for Set up USB game controllers. Find your controller in the list. It might say PPM device or something generic, and click Properties.
Right.
Third, check the Test tab first. Wiggle the sticks, flip switches. You should see the indicators move. This confirms Windows is seeing some input. Then fourth, go to the Settings tab and click the Calibrate button. Follow the wizard carefully. It'll ask you to center the sticks, then move them through their full range of motion corners. Everything. Complete that wizard.
Okay, so connect, power on, find controller, test input, then calibrate via the wizard.
That's the sequence. Get that Windows calibration perfect, then you go into your simulator.
And the calibration inside the sim is just for assigning channels, setting up curves, expo, that kind of thing.
Exactly. The sim calibration builds on top of the correct Windows foundation. You can't fix a bad foundation with in-sim tweaks.
Makes perfect sense. Okay, let's pivot quickly to troubleshooting. We've hit the big one, wrong cable. What's next if the PC doesn't see the device, assuming the cable is the right simulator type?
And the transmitter is powered on. The next thing to check is inside the transmitter's own menu system. Many FAQs radios, especially older ones, have a setting like trainer mode or student mode that needs to be explicitly turned on to activate the signal output on the trainer port.
Ah, like a safety switch almost.
Yeah, it prevents the port from being active all the time. So dive into the system settings or RX setup menus on your radio and look for anything related to trainer, student, or PPM output and make sure it's enabled.
Good tip. Okay, what about the opposite problem? The device is seen by Windows, maybe even calibrated okay, but you get zero response in the simulator itself.
Well, assuming the Windows calibration test tab showed movement,
Yeah.
then it might be specific to that simulator. Did you maybe forget to assign the axes and buttons inside the simulator's controller setup menu?
Right, the two-stage calibration. Windows first, then mapping inside the sim.
Exactly. You have to tell the sim which detected axis corresponds to throttle, which one is steering, and so on.
Okay, and one more for the DIY mic core people. If the controls are super jittery, like the virtual plane is having spasms.
Almost always. That's the microphone input level in Windows sound settings being too high. Remember, the software, like SPP, is interpreting an audio waveform. If the input volume is cranked up too much, the signal gets distorted or clipped. The software can't read the pulse timings accurately.
So turn down the mic volume.
Yes. Go into Windows sound settings, find the properties for your microphone input, and lower the level or gain. Start maybe around 50% or 60% and adjust it down until the jitter smooths out. Too low and it won't register. Too high and it gets noisy. There's a sweet spot.
Useful. Okay, last area, the simulators themselves. Do these generic Flisky connections work flawlessly with every single sim out there?
Not always. It's important to manage expectations a bit. Some high-end simulators, Real Flight comes to mind, are really optimized for their own specific hardware controllers. While they might work with a generic dongle, you sometimes lose functionality. For example, if you're using an older 6-channel radio like the FSI-6, you might not have enough channels to map things like flight mode switches or the instant reset button that the dedicated controller has.
So basic flying might work, but advanced features could be limited by the radio's channel count.
Correct. And then there are some older sims. Phoenix RC is notoriously difficult sometimes with generic dongles. You might find you need to install extra background software, little helper programs like VJoy or UJR, basically to trick Phoenix into thinking it's seeing a controller it recognizes. It can be a real hassle.
So compatibility isn't guaranteed across the board, especially with older software.
Generally, yeah. The good news is that most modern simulators, especially things popular for FPE drones like Liftoff, DRL Sim, Velocidrone, or even car sims like VRC Pro or BeamNG.Drive, tend to have much better support for standard generic USB game controllers. They're usually less picky.
Okay, good to know. So let's bring it all together. What are the final recommendations?
Well, for maximum simplicity, if you're buying new or upgrading, seriously consider a modern transmitter that has that native direct USB capability, like the Flesky Noble NB4, the FSI-6S, or the FSG-7P. That bypasses probably 90% of the headaches we've talked about.
Just plug and play mostly. Use a data cable. Calibrate in Windows.
Pretty much. But for the thousands of folks out there still happily using older workhorses like the FSI-6, which is a great radio, diligence is key. First, make absolutely sure you buy a decent quality, well-reviewed simulator adapter dongle like the SM100 or a known good clone. Avoid that firmware cable like the plague for sim use. And second, be absolutely meticulous about the two-stage calibration. Nail the Windows OS calibration first, then do the in-simulator mapping.
Right. Don't skip that Windows step. And all this effort, it's worth it, right? Simulator practice is
Oh,
huge.
massively.
Yeah.
It is the single most cost-effective way to improve your skills. Developing that precise muscle memory in the sim saves you potentially hundreds, even thousands, in real-world repair costs. Every crash in the sim is free. Every crash in the real world costs time and money.
Couldn't agree more. It's the best insurance policy.
Absolutely. And maybe a final thought for you listening. Instead of immediately rushing out and buying the most expensive, feature-packed simulator software, maybe start simpler. Grab a free simulator, or a low-cost one known for good compatibility, like maybe the VRC Pro demo, or pick a sim for basic flight, or even FMS if you can find it. Your very first goal shouldn't necessarily be to learn complex maneuvers. It should be just to validate the connection. Confirm that your specific radio, your chosen connection method, dongle, USB, mic port, and crucially, that Windows calibration are all working together perfectly before you invest heavily in premium software. Get the hardware talking first, then focus on the flying.
Excellent advice. Validate the foundation before building the house. Thanks, that clears up a lot of common frustrations.